Hi, this is Mr. Erdman. This is 11.6 in geometry. We're talking about ratios for area, perimeter, volume today. So we have a rectangle. It is 3 by 2. So if the base is 3, the height is 2, what is the perimeter? Well, it would be 3 plus 3 plus 2 plus 2, or 10. What is the area? 3 times 2 is 6. So that would be centimeters squared. Now we have one that's 6 by 4. What is the perimeter? 6 plus 6 is 12, plus 8 is 20 centimeters, and then our area would be 6 times 4, or 24 centimeters squared. We have a 9 by 6 rectangle. The perimeter 9 plus 9, and 6 plus 6 would be 30 centimeters. The area would be 9 times 6, or 54 centimeters squared. In our last rectangle, 12 by 8, would be 24 plus 16, which would be 40 centimeters. Our area would be 96 centimeters. That should make some sense. Okay, now, what happens to the rectangle when the base and the height are multiplied by 2, and then by 3 or 4? So, if we have our 3 times 2 and our height is 3 times 2, so that would be the new height, base would be 6, the new height would be 4. So the perimeter would be 20. But what was our original perimeter up here? 10. So 10 over 20, it's 2 times bigger. Now if we multiplied the 6 by 4 by 2, it would be 12 by 8. Our perimeter would be 40 centimeters. Okay, and then the old one up here would be 20 centimeters. So 40 over 20, it's 2 times bigger. And then if we multiply our 3 centimeters up here by 3, we get 9. 2 by 3 would be 6. Our new perimeter would be 30. Our old up here at this one, 3 by 2 is 10. It would be 3 times bigger. Okay. Same thing if we had one that's 9, multiplied by 3, we'd get 27. Our 6 we multiply by 3 would give us 18. So our perimeter would be 90. Our old one up here is 30. 90 over 30 is 3 times bigger. Now if we take our 3, we multiply it by 4, make it 4 times bigger, it's 12. Our 2 would be 8. Our perimeter would be 40. But our original one would be 20. So 40 over 20 is 4 times bigger. And then if we take our 12 down here and our 8, our perimeter would be 160. Our original was 40, is 4 times bigger. So basically what this is trying to tell us is if we double our side lengths, the perimeter doubles. If we triple our side length, our perimeter triples. If we make it 4 times as big, the sides, our perimeter is 4 times as big. Okay, now if we do the similar thing with area, if we have our 3 by 2, we make our sides twice as big, our area would now be 24. But if we looked at our front, our original area up here was 6. So 24 over 6 is 4. Same thing, we take our 6 by 2, our 6 and by 4, we made it 12 by 8. Our area would be 96. Our original over here was 24. 96 over 24 is 4 times as big. Now, if we take our 3 by 2, we make it the sides 3 times bigger. It would be 9 by 6. Our area would be 54, but originally it was 6. So 54 over 6 is 9 times bigger. So our 9 by 6, we make it 27 and 18. Our volume would be 486. Our original volume is 54. 486 over 54 is 9 times bigger. And then if we do the one where 3 by 2, we make it 4 times bigger, it's 12 by 8, would be 96. Our original area was 96. It is going to be 96 over 6 is 16 times bigger. And then our 12 by 8, if we make it 4 times bigger, it's 4832. It's 1,536. Our original, the front sheet, was 96. 1536 over 96 is 16 times bigger. So what's happening here, if we double our sides, it's 4 times bigger. So 2 squared is 4. If we triple our sides, our area gets 3 squared, or 9 times bigger. And then if we make the sides 4 times bigger, 4 squared is 16. So it's 16 times bigger. Okay, so suppose both dimensions are multiplied by 5. So at the perimeter, what would happen is the perimeter would be 5 times bigger. On our area, it's basically 5 squared, or 25 times bigger. So the similarity ratio, or the side ratio, like here, we multiply the sides by 2 and 2, our perimeter would be 2 times bigger, but our area would be 4 times bigger. So whatever factor you have, if you use find the area, your area just gets 5 times bigger. If you do the area, you got to square whatever that factor is. So if we would say, if it was 6 times bigger, the perimeter would be 6 times bigger. The area be 6 squared, or 36 times bigger. So 2 rectangles are similar with a scale factor of 1 to 3. So it means their sides are 1 to 3. What is the factor of their perimeters? Well, 1 to 3, this is basically 3 times bigger. So if one side was 1, one side would be 3, the perimeter would be, of the bigger one, would be 3 times bigger. What about the area? Well, we got to take 3 squared, or 9 times bigger. If the similarity ratio of 2 similar figures is A to B, then the ratio of the perimeters is A to B. Or you can write it as A over B as a fraction. So if one figure, the side was 3 and the other one was 5, the ratio would be 3 to 5, or 3 over 5. Their area ratios would be A squared to B squared, or A squared over B squared. Using 3 to 5, it would be 3 squared over 5 squared, or 9 over 25. 9 over 25 would be our area ratio. Or you could do it 9 to 25. Okay, how we're going to use that? The area of a smaller regular pentagon is 27. So the smaller one, 27.5. Find the area of the larger pentagon, which is x. Well, we're going to use our similarity ratio first, 10 over 4. We can reduce that to 5 halves. Now, this is our side ratio and our perimeter ratio. What we're doing up here is if we had our area ratio, we'd have to square these. So it'd be 5 squared over 2 squared is 25 over 4. This is now our area ratio. So now we want to find our bigger one, is x. Our smaller one is 27.5. Larger, smaller, larger, smaller. So if we cross-reference, we'd have 4x equal 687.5 divided by 4, 687 of these two, would be 171.9 centimeters cubed. So the key thing here is getting our area ratio to solve this. All right, so most of these are word problems. The similarity ratio of two dimensions of two similar pieces of glass is 3 to 5. So that is our ratio. If the smaller piece costs $2.50, what should the cost of the large one be? Well, the smaller one is $2.50. It goes on the top. Okay. And the bottom one is what we're trying to find out. But the glass is an area, so we have to square these. So it'd be 9 over 25 equal $2.50 over x. If we cross multiply, we get x equals $6.94. Just got multiply, cross multiply, and then you divide by 9. Okay, what is the similarity ratio of the figures if the areas are 50 and 98? So our two areas are this. So the first thing we want to do is, can we reduce this? Yes, we divide them both by 2, we would get 25 over 49. Now, when we went from the perimeter or the similarity ratio, which is the side, let's do 5 over 7, and we wanted to get the area ratios, we'd have to square them. 25 over 49. Now, if we have the area and we want to go backwards, we have to take the square root. So the square root of 25 is 5. The square root of 49 is 7. So 5 over 7 would be our perimeter ratio and our similarity ratio. If one side of a larger figure in an example is 16, find the corresponding side of the smaller. Okay. Oh, so in the last example, so we have 5 over 7 is our similarity ratio. The larger side is 16. This is bigger, 7 is bigger, so we'd have x over 16. So if we cross multiplied, 7x would equal 80. Divide by 7, x equals 11.47. If two figures have a scale factor of 3 to 4, so that's their scale, their similarity ratio, the perimeter of the larger one is 36. What is the perimeter of the smaller one? Well, the similarity ratio, perimeter ratio are the same. So it's saying 36 is the larger. We're looking for the smaller. So cross multiply, 4x equals 108. Divide by 4, x equals 27 centimeters. In the figure above, the smaller figure, the area is 18 centimeters squared. What is the area of the larger one? Well, we have to start with our similarity ratio and square it to get our area ratio. Now we can set that equal to 18. 18s are smaller, that goes on top. We're looking for x. So cross multiplying, 9x equals 18 times 16 is 288. And then we just divide by 9, x would equal 32 centimeters squared. All right, so similar polygons. We're going to use those ratios. Okay, we have two parallelograms. This side is 12, this side is 8, this is 9, and we don't know this side. What is the scale factor? So to find the scale factor, we take the sides that are corresponding or matching, and we set up a ratio, 12 over 8. Now that can be reduced, both of them, by 4, 3 over 2. So that is our scale factor or our similarity ratio. The ratio of the perimeters is the same as our scale factor or our similarity ratio, so it's 3 over 2. To find the area ratio, we just square that ratio, give us 9 over 4. So now if we want to find FG up here, we would use our 9 over 4. So FG, when I say, is x. That's on the smaller ones, that goes on the bottom. It matches with 9 over here. So if we cross multiply, we get 9x. Equals, what do we have here? 9x equal 36. Did I do that right? Oh, I made a mistake. we're going to use 3/2 because 3/2 is our side or similarity ratio. That would be 9 over x. So 3x equals 18. Divide by 3, x equals 6 centimeters. So this would be 6 centimeters. Now the perimeter, we can find out the perimeter of each of them. 12, 12, 9, and 9 would be 24 plus 18, which is 42. Now the smaller one, 8, 8, 6, and 6 would be 16 plus 4, 28 centimeters. Now we could have done 3/2 of this one to figure out our other one. We just added them together. Find the area using the ratio if the ABD, so if the first one is 72, for the bigger one, we want to find our smaller one. Well, our area ratio is 9 over 4. So if we cross multiply, 9x equals, what is that, 288? Divide by 9, x equals 32 squared. All right. So now we're going to go to the volume. Okay, the ratio of surface area, we did our ratios are a squared, b squared, or a squared over b squared. So if our similarity ratios are a to b, area is a squared to b squared. Our volume is a cubed to b cubed, or a cubed over b cubed. So perimeters are linear measurements. They're in the same units. So same. The ratio would be a to b. Area is squared. That's how we get a squared, b squared. And volume is cubed, which is a cubed, b cubed, when we do our comparison. So, two prisms have a scale factor of 2 to 3. The total area of the larger is 108. Find the area of the smaller. Well, we have to square this to get our area ratio. Now the larger is 198. That goes on the bottom. So if we cross multiply, 9x would equal, that's 792, divide by 9, x equal 88 inches squared. Okay, if two prisms have a scale factor or a similarity ratio of 3 to 4, and the volume of the smaller is 54, what is the volume of the larger? Well, we have to cube this now to get our volume ratio. So it would be 27 over 1648, 64. So then this is the smaller, 54 over x. So 27x would equal 54 times 64. Then we're going to divide by 27. This just makes it 2, so it's 128 centimeters cubed. The surface area of two similar solids is 160 over 250. That would be our area ratio. The volume of the larger one is 250. Find the volume of the smaller one. So we got to go to area to our similarity ratio or our side ratio. So if we divide both of these by 10, we get 16 over 25. Now if we take the square root, that's how we get back to the area ratio. It would be 4 over 5. That's how we have to take the square root. Now if we want to get to the volume ratio, we have to cube these. So 4 cubed is 64, 5 cubed is 125. Okay, now we can set up a ratio. The larger volume is 250 over x. So cross multiply, 125x equals 64 times 250. We divide by 125, that gives us 2. 64 by 2 is also 128 meters cubed. The volume of two solids are 128 and 250. The surface area of the larger is 250. What is the surface area of the smaller? So now we have to go from our volume ratio to our similarity ratio. So if we divide both of these by 2, we get 64 over 125. Now from up here, we just did the opposite. We cubed them. If we take the cube root of 64, we get 4. The cube root of 125 is 5. Now we got to get our area ratio. So we square 16 over 25. So if the surface area of the larger is 250, cross multiply, 25x equals 16 times 250, and we have to divide by 25, goes 10 times, x equals 160 meters squared. All right, so that's pretty much the new stuff. There's just a few problems if you want to try these. The volume of the prism is 10 inches cubed and the total area is 34. Suppose another rectangle's dimensions are 4 times larger. What is the second prism's total area? Okay, so if it's 4 times bigger, 1 over 4. We have to square that to get our area ratio, 1 over 16. Okay, volume, total area is 34. So if this one is 34, we want to find x. So cross multiply, x equals 544 inches squared for the larger one. So marble paper weight weighs 0.15 pounds. How much does a similar paper weight weigh if the dimensions are 3 times bigger? Well, that is a volume weight is. So we have 1/3 is our similarity. So we have to cube these. So it'd be 1 over 27 because we got to get a volume ratio. Now, if our smaller one is 0.19, we want our bigger one, we cross multiply. X would equal 4.05 pounds. Okay, if the volume of a prism is 10 centimeters and the total area up there, suppose another rectangular prism are 5 times bigger than the first one. So that would be 1 to 5. What is the second prism's volume? Well, we have to cube to get the volume. 1 over 125. So the smaller one is 10. We want the larger. Cross multiply. X equals 1250 centimeters cubed. There are 750 toothpicks in a regular box. If the jumbo box is made by doubling all the dimensions of the box, how many toothpicks will be in there? So this is a volume one again. So if we double it 1 over 2, we have to cube 1 over 8. So it would be 750 over x. Now we cross multiply. X equals 750 times 8, or 6,000 toothpicks. And then our last problem. A rectangular prism with edges 9 along its enlarged to a similar prism with base of 36. Well, 9 over 36 is 4 times bigger. Okay. By what factor is the volume increased? Well, how do we get from a similarity, how do we get a volume ratio? We cube it, which would be 1 over 64. So it would be 64 times larger. All right, that's all for 11.6. Good luck on your worksheet.